In this video, I'm going over the questions from the Quiz 4 review. So starting with our inverse functions of our logs and exponentials. So notice here how when writing again with our inverse, we need to first switch that x and y. Remember, f of x is the same as y. So x is equal to log of 2y plus 1. Now notice we have a log, so we need to end up with an exponential. Now always get the log or exponential by itself. Notice how everything is all grouped together inside the parentheses as if it's part of the log. So that means that the log here is by itself. So now we can convert this to the exponential. Here we have our common log, which has base 10. So this is 10 to the, well, what is the exponent? 10 to the x, which is now equal to 2y plus 1. And now we can solve for y. Notice how you have a two-step. So subtract 1 here from both sides. Sorry, running out of space. So 10 to the x minus 1 is equal to 2y. Then here, divide both sides by 2. So here, your inverse function is 10 to the x minus 1, all divided by 2. So then here, same thing. We're going to switch that x and y. So x is equal to log base 3 of 8x. So again, notice how the log here is again all by itself. Nothing outside of it is being added or subtracted or multiplied or divided. So here we go. Converting to our exponential, we have a base of 3. So 3 to the x. Oops, sorry, as I just realized, I put two x's here because I was supposed to switch them. So that's 8y. So 3 to the x, which is now equal to 8y. So now solve for y. Divide both sides by 8, and you end up with the inverse, which is 3 to the x divided by 8. So now question number 2, we're finding the inverse again, but of the exponential. So we're going to switch the x and y. So 2 to the y plus 5. Now notice how this exponential is not by itself because you're adding 5 to it. So I can't write it as a log until we subtract 5, get the exponential here by itself. So now I've got x minus 5, which is equal to 2 to the y. Now notice how the exponential is by itself. We now can convert it to a log. So here we have our log, which is log. Well, what is the base? Base 2. Log base 2 of x minus 5. Now see how we already had all of the x minus 5? So make sure to keep it all together in parentheses, which is now equal to y. Notice how y was by itself. So this is our inverse. So same thing here. We're going to switch the x and y to solve for y and get our inverse. Now, notice again, the exponential is not by itself because you're subtracting 1 here on the outside. So we're going to add 1 here first. So x plus 1 is now equal to 4 to the y plus 7. Now notice the exponential is technically by itself because y plus 7 is all within the exponent. So now we're going to write it as our log. So log, then what is the base of the exponential? 4. So log base 4 of x plus 1. Again, notice how it was all grouped together, so keep it all grouped together, which is equal to y plus 7. Now notice y is not by itself, so we're not done. We don't have the inverse yet. We're adding 7, so now subtract 7 last. Y is equal to, so our inverse function is log base 4 of x plus 1 minus 7 on the outside, because that was our last step there. And so now with our number 3 here, again, writing the inverse, but of our natural log and e function, so our exponential here as well. So again, we're going to switch the x and y. So x is equal to the natural log. Now again, notice how our natural log is by itself. This is all grouped together. So we can now go ahead and get our inverse of natural log, which is e. What we do to one side, we're going to do to the other side here. So this is e to the x, right? Because e is our exponential, which is equal to, remember, right? Our inverse functions cancel out. And really, you're just left with y plus 4. So now notice to solve for y, Just subtract 4 here now from both sides. And y is equal to e to the x minus 4. So same thing here. Again, let's switch the x and y. Remember, f of x is y, which is equal to e to the y minus 2, then plus 6 here. Now notice the exponential, our e function, is not by itself. Notice how we're adding 6 on the outside. So that's why you need to first subtract 6 from both sides. So now you've got x minus 6, which is equal to e to the y minus 2. Now here we have e by itself because this is full exponent here. So now we can do natural log, the inverse. And what we do to one side, you do to the other. So now you've got the natural log of, notice how we had all of x minus 6, so keep it all together, x minus 6, which is now equal to, notice again, our inverse functions will cancel out, and you bring down y minus 2. So now notice the last step here is just to add 2 to both sides to get y by itself. So here we've got the inverse function, which is the natural log of x minus 6, but plus 2 on the outside. So now question number 4. Notice how here we have our inverse functions, ln, natural log, and e. So these two will cancel each other out because they're inverse and bring down x plus 6. Then plus, same thing here. Inverse functions cancel each other out, so we just bring down 5x. Then combining like terms, x plus 5x is now 6x plus 6. Now, 5 and 6 are our application. So here we have an investment of $800. So that's our principal. We have our interest rate of 5.8% or 0.058. The interest is compounded continuously. So because of continuously, we're going to use PERT or E, that function E. And then for 5 years. So that's your T. We are looking for the final amount. So A is equal to, remember, right, we're continuously, so 800 times, we're not using parentheses and 1 plus like with our compounding, we're doing 800 times our function E. So E to the 0.058 times 5 is as your exponent, the rate times time. And now you can put all of that in the calculator. And so once you put this here in the calculator, you should get that the final amount is approximately $1,069.14. And so now here in question number 6, a little different. How long does it take? So now we're looking for the time. How long? How many years? Does it take for an investment of $5,000 to quadruple, meaning we are multiplying by 4 with our interest rate of 5.5% or 0.055 and then compounded continuously. So because again, the continuously, we are going to use our function E here. But now we're quadrupling. So we're starting at $5,000, which means if we're quadrupling, what are we ending that? Well, we're multiplying that by 4, which is 20,000. Now, keep in mind, there's different ways that you can set this up, and I'll show you both ways. So here quadrupling, and then I've got e to the 0.055 times t power, right? Because we're solving for t. Now focus on, we got to get solving for t, but right now it's in the exponent, we got to bring it down. But before we do that, we got to get e here by itself. Right now it's being multiplied by 5,000, so now I'm going to divide by 5,000. So now here you end up with 4. So 4 is equal to e to the exponent of 0.055 times t. Now notice e here is by itself. So now to bring this down, we continue with our inverse, which is the natural log. What we do to one side, we do to the other. So notice how this is not 4, but this is the natural log of 4, which is equal to, notice again, inverse functions will cancel out and bring down. So you're left with 0.055 times t. So now here, solve for t, if it's being multiplied, then divide by 0.055. And you end up with the time is approximately 25 years. Now, there is another way that you could solve this, because if you notice, and we talked about this, what if we weren't given the 5,000, right? If this just said that we quadrupled, well, quadruple means 4. So 4 is equal to e to the 0.055t, which really we ended up with here before we took the natural log. So notice how you could have set this up a bunch of different ways, and no matter what, you'll still get to the same answer. So now in question number 6, this is a double start, but I'll still go through this. We are given this function here, an exponential, where x, y, and z are all positive, but we're going to write the inverse, the logarithm, by solving for a. Well, notice how a is in the numerator, or not in the numerator. Oh my goodness, I don't know why I just said that, y'all. It's in our exponent. So that means first, so let me rewrite this. So here, x is equal to y times 5 to the az. Well, first, just like before, we've got to get the exponential here by itself, and it's being multiplied by y. So we first need to divide by y. So x divided by y is now equal to 5 to the az power. Now, notice our exponent is by itself. So we can convert to our inverse, which is the log. Now, what is the base? Well, the base is 5. So log base 5 of x divided by y. Notice how here, keep it all together because it was all together before, which is equal to a times z. So now notice we're solving for a, but it's still being multiplied by z. So then divide both sides by z. Notice how you're going to divide everything by z. So a is equal to the inverse, solving for a is log base 5 of x divided by y, which is all still divided by z. And so now getting into our spiral questions, focusing on the transformation here. Remember, anything inside is opposite and horizontal. So this is our horizontal. Everything outside is your vertical and shifting. Like for example, 1/3. Well, that is your vertical shrink here, and it stays by a factor of 1/3. Also here on the outside, you have +4, which means you're going up 4 units. Now notice the negative on the inside. So the negative on the inside, anytime you have a negative, right, we always had a reflection. But now we're reflecting over the y-axis. So outside is x, inside is y. Now here we're continuing with the inside. We have here our value of 2, which shows our horizontal. Now, remember opposite, so this is a factor of not 2, but 1/2. So because it's 1/2 or less than 1, this is also a shrink. Then here you also have x plus 1, which is again the opposite. So you're going 1 to the right, not to the right, but to the left. So again, opposite. So now question number 8. The cost to enlarge a photo is given by this function here. Notice how you have a cubed value, where w is the width. Notice here we're looking for the equivalent, which is solving for w. So I'm going to rewrite it out here. So c is equal to, and notice how we're solving for w. Well, again, we have multiple things going on. We can't take the cubed root just yet because we have, think about it like a 2-step. We always add or subtract first. We're going to subtract 2 here from both sides. So now here I've got c minus 2, which is equal to 0.4 w times w to the 3rd power. Now you're multiplying that w by 0.4, so now divide by 0.4. And so now here we've got, sorry, running out of space. So c minus w divided by 0.4, all equal to w cubed. Now that the w is by itself, we can take the cubed root. And because we already had this full fraction, you're taking the cubed root of the entire both numerator and denominator. So that's why the answer is A. Now question number 9. Here we have another application. So we have a principal amount of $300 deposited into the account with 6.5% interest or 0.065, compounded but weekly. So that means now we have a value for n, and there are 52 weeks. So n is equal to 52. What is the balance after 6 years? So again, A is equal to 300, the original, times 1 plus, now we have that fraction. So we have our rate, which is 0.065, divided by n, which is 52. Then raise that to the 6th power, but don't forget to take this value of t here and also multiply it by your n value again, which is 52. And when you put all that in the calculator, you will get the approximate final amount of $442.99. And so now in the next one, we're looking to see which function represents our situation here. So the city population initially was 25,700 people, but now the population has been dropping. So if it's dropping, we have decay, or we're going to be subtracting 1 minus our rate. So automatically, I'll go ahead and use test taking strategies and mark off A and B because that shows growth. Then we have our percent, 4%, or 0.04. Move the decimal 2 times or divide by 100. So I can already tell that's why the answer here is C, because notice here how you have the wrong rate here. Now, question number 11. We're going to select 3 statements that apply here about our exponential. Notice how we have an exponential. So here, whenever you have an exponential with your domain and range, well, what is all reals? The domain is all reals. So A is one of our answers, not B. Then here, and then really nothing else is about the range. So I'm going to continue on. We have always, for an exponential, the horizontal asymptote. So notice how here we have a horizontal asymptote crossing our y-axis. So y is equal to -3. So that's why the answer here is D and not C. Now let's look at the end behavior. As x's are approaching infinity, so as we're going to the right, well, what is the right side approaching? Well, yes, it's going down, but is it going down to -infinity? No, it is approaching the asymptote at -3. So this is -3. So let's check to make sure that F is our third option. As we're going to the left to -infinity. So as we're going left, well, what direction is our end approaching? Well, it's going up to +infinity. Now, question number 12, which statement is false? So now keep in mind, we are focusing on a radical function. So I'm going to identify my starting point, which is at 2, -1, which is my x here and my y. So let's start with domain, because I see I have a domain option. Well, the domain, remember, right, that's your x's. So going left and right is your x-axis. So the x values are starting at 2 and going less than, because we're going to the left. So less than or needing -infinity, but this shows positive, so D is, oh, that means D is false. So there you go. So let's just check and make sure everything else is true. Remember, your interval is always x values. Read the graph from left to right. We are going down decreasing, starting -infinity here on the left and stopping at the x value of 2. So this is true. Then the end behavior. As x's are approaching infinity, as we're going to the right, what's happening on the right? Boom, we're stopping at what y value? -1. So B is true. C, as we're going to the left to -infinity, what is our end doing? Well, we're going up to infinity. So C is also true. Now question 13, which statement is true about our log function here? So here I notice, well, let's check to see what type of asymptote we have, because I noticed we have two answers here about the asymptote. So let's see if either of those are true. Remember, for our log, we have that vertical asymptote, which is here at x is equal to 1, because we're crossing the x-axis at 1. So that means we're saying the answer is C. Let's check that the others are false. The interval of increase. Well, remember, interval again is x values, but remember, are the x values starting in negative infinity? No, they're starting at 1 from the asymptote, so B is false. Then here, our end behavior as x's are approaching, well, are the x's going all the way into negative infinity? No, the x values only go to 1. So that's why C is the true statement. Now 14 through 16 are our exponent rules. First, to simplify, let's rewrite. So this is b to the 7 over 5. Keep that exponent up top. Then notice you have power to a power. So we're going to multiply 3 times 2 fifths. That gives you b to the 6 fifths. Now notice we're dividing. Bases are the same. Subtract top to bottom. So 7 fifths minus 6 fifths, which gives us b to the 1 fifth. Now here, question 15. Let's rewrite again as well. So this is a to the 12 over 4. And this is a to the, not just 10, because remember this is a square root with an index of 2, so 10 over 2. Now we can't necessarily subtract, but I can simplify. So this is a to the third because of 12 divided by 4, which is 3. Then this is a to the fifth because 10 divided by 2 is 5. Now I can subtract top to bottom. 3 minus 5, which is a to the negative 2. Or, remember, right, you have a negative exponent, so this is 1 over a to the second power. Then question 16. We are dividing, but we can't do anything with the exponents in the numerator because the bases are different. Notice how the bases also got switched here, so here's our x's. So again, we're going to subtract, but the bases have to be the same. So this is x to the 2 minus 7 fourths. Then for our base of y, we're going to subtract top to bottom again. So 9 fourths minus 13 fourths. So now here I end up with 2 minus 7 fourths, which is 1 fourth. Then here for our y, base of y, 9 fourths minus 13 fourths is negative 4 fourths, which actually simplifies to negative 1. Now, notice y has that negative exponent, which means this needs to go, that base needs to go in the denominator, leaving you with x to the 1 fourth over y, because again, y, the base of y, had the negative exponent. And question 17, going back to our cubed root function. Notice here how we have that the shape here and going on and on in both directions. So this is our cubed root function, which means for the domain and range, because we're going on and on in both directions, left and right and up and down, both the domain and range are all reals. So if we're looking for the true statement, I'm going to cross off A and C. Now let's see here. The f of x values, so the values of our function, are negative over the interval. So x values from 0 to 2. So looking at x values from 0 to 2, so we're looking at this portion of our graph, are those values negative? Yes, because notice how this portion here of f of x is below in the negative range. So B is our true statement. So now let's check. As x's approach infinity, so as we're going to the right to infinity, what is f of x approaching? Well, we're going up to infinity, but this says negative. So that's why the answer, oh my goodness, guys, as I just said, that was false. So that's why here the answer was B.